Hello and welcome to INE's CCI Service Provider version 5 Learning Path. Today in this course we will talk about Isis Bfd, basically configuring Bfd on Isis. So as you know, Bfd, which is bidirectional forwarding detection, it's a super fast protocol. It is basically used to detect link failures, which can happen. You can basically detect link failures even within a microsecond or even a millisecond. All routing protocols, you look at OSPF or EIGRP, they have their inbuilt mechanism which is available for detecting link failures. For example, OSPF uses hello packets and dead interval to detect link failures. EIGRP uses, again, hello packets and hold on timers to detect failures. So all these protocols, they have this thing built in. However, the problem is that imagine if you have networks that use real-time traffic, for example, voice. They require super fast convergence. What's the problem in that? Now, OSPF, ISIS, EIGRP, they all can detect link failures and they can change their routing table or they can change their path in the routing table only when the neighbor goes down. And for the neighbor to go down, that takes time, which can cause problems in traffic that is using real time, for example, voice. So, however, we could tune OSPF or EIGRP or even ISIS to do fast convergence. Even if the link goes down, maybe we could change the hello and dead interval on OSPF. If you know that in OSPF we can change the dead interval to be 1 second, as low as 1 second. But the problem is that all these protocols which have their inbuilt mechanism for detecting link failures, the problem is that they were never designed for sub-second failure. So if I want something to be faster, I could use another protocol which is BFD. BFD does not have any overhead because the packets are basically processed by the line cards or basically your line modules. If you look at OSPF, the packets are processed by the control plane, which can cause a lot of overhead. The best part about BFD is that it is independent of any routing protocol. So you could use BFD with OSPF, EIGRP, ISIS, BGP, MPLS, HSRP. You could use BFD with any of these protocols. Now, let me give you an example of how BFD would actually work. Let's say we have two routers and both the routers are running OSPF or maybe ISIS. They are still sending hello packets if it's OSPF between the two routers, or they're sending LSPs between the two routers. OSPFs or ISIs, they will still have their control plane link failure detection mechanism, which could be 40 seconds in OSPF by default if it's a point-to-point, because your hello is 10 seconds and your dead interval is 40 seconds. Even if I tune that to maybe change my dead interval to be 1 second, there's still going to be a problem because now there's no concept of sub-second configuration in OSPF or even in ISIS. The maximum, the lower I could go would be 1 second. But what if I want to detect failure in less than 1 second, maybe in milliseconds or microseconds? I could achieve that with BFD. So how it works is that the control plane hellos are still being exchanged between the two routers within OSPF. BFD is going to basically exchange control packets with each other. Both the routers are going to exchange packets with each other. And I can tune that maybe I will send you a BFD control packet every 50 milliseconds. And I should receive a response back from you in about 50 milliseconds again. So as soon as a link detection is detected, let's say if you don't send me a response back, BFD would inform OSPF or ISIS that this link has failed, and immediately your neighbor goes down and the packets or your router will reconverge as per the new path. So you can configure BFD globally under the ISIS process, or you could do it per interface basis. Same thing in OSPF also. You could do it globally or you could do it under the interface. The command to configure BFD is BFD interval. Under the interface, you define at the milliseconds at which I would be sending you a BFD control packet and at what time interval I should receive back, and then maybe a multiplier of could be 1, could be 2, could be 3. So let's say if I give something like BFD interval 50, and minimum receive time would be again 50, multiplier as 3, which basically means that I could detect a link failure in approximately 750 milliseconds. So here is an example of the configuration of BFD on an iOS XZ router, where I go to my interface and I define the BFD interval. So I would say BFD interval 250, and minimum RX is 250 again, and multiplier would be 3. This means I would detect this in 750 milliseconds. If I give this as 50, minimum RX would be 50, multiplier would be 3, I would detect this in 150 milliseconds. That's how fast BFD can work. The lowest value is 50, so it basically tears down your OSPF or ISIS adjacency so that you can reconverge as per the new path. Without BFD, yes, you will eventually converge, because OSPF will bring down the neighborship in 40 seconds, ISIS will bring down the neighborship, and once the neighborship goes down, only then I would reconverge as per the new path. But with BFD, it just speeds up your process and there's no additional overhead, because all of these protocols, they were never meant to have sub-second link detection failures, to basically detect the failures in sub-second. And they were never used for, they were basically never used for managing your control plane for link detection, because it causes a lot of overhead. But with BFD, there is no overhead. So let's in fact configure this. We take two routers. Maybe I'll take two iOS XZ routers, which will have ISIS pre-configured, and then we would implement BFD. We'll see without BFD first what happens with how much time it takes for it to reconverge to the next path, and then we'll see with BFD implementation how fast it converges. BFD as of right now is not supported on XRV. It will still accept the command, but it won't actually send control packets across that link. So as far as the lab exam is concerned, you would never be tested for BFD on XRV. You would only be tested on iOS XZ. All right, so here I have some routers which are pre-configured for ISIS. So let's look at this router 2. And if I do a show IP route ISIS, I have all the routes in my routing table. Let's look at a specific route, which is this one, towards 5555. Right now, it is transiting router 4 to get to that destination. I have not configured a BFD at this point of time. So if I do a trace route to 5555, I am transiting router 4 and then reaching router 5. Now let's do a ping, and I'll shut down the link between router 2 and router 5. I'll shut down the link, in fact, between 2 and 4, and we would see that how long does it take for router 2 to converge to get through R5 through another path. So let's do a ping to 5555, repeat 100,000, and let's go to 4 and shut down the link towards R2. The minute I shut down, you would see basically some drop packets. So I see 1, 2, 3. I saw three drop packets here, which basically means about 6 seconds of downtime I had in ISIS. And after 6 seconds, ISIS could reconverge that, okay, I have another path, my neighbor went down, and I have another path available, and it starts routing through maybe R3. So without BFD, this could cause problem with delay-sensitive traffic or traffic which uses real-time applications like maybe voice traffic. This could cause a problem there. So ISIS does have an inbuilt mechanism to detect the link failure. It's just that it is slow and CPU intensive because it is managed by the control plane. So when I configure BFD, let's look at the changes that's going to happen, how fast my convergence can happen, and how fast router 2 should be able to reach router 5. And again, my CPU utilization would be much lower because BFD control packets are not processed by the control plane, it is processed by the line cards or the line module. So let's go and test this. So I will configure BFD on my router 2. Let me first go back to router 4 and do a no shut, and go back to 2. On the link between R2 and R4, I will configure BFD. So that's done by going to interface gig 1.24 and define the BFD interval as, let's say, 50 milliseconds, and my minimum RX receive time would also be 50, and multiplier would be 3. Again, if you remember, I told you earlier that we could activate BFD under the interface by saying ISIS BFD. I could do that, or I could do it globally under the ISIS process by going to router ISIS and saying BFD all interfaces. Let me show you that command also. That's going to be under router ISIS, and you say BFD all interfaces. This activates the BFD for ISIS on all its ISIS enabled interfaces. So since I don't want it on all the interfaces, I just want it on a specific interface, I would do it under the interface, which would be ISIS BFD. And now if I go back and do a show BFD neighbor detail, you would see that, okay, I have configured BFD. Right now it is admin down, and it's not up and running. My routing protocol, or the registered protocol, is ISIS. Ceph is automatically registered. Let's go to router 2 also and do exactly the same thing. So BFD interval 50, minimum RX would be 50, multiplier 3, and then say ISIS BFD. Once I do this, if I do a show IS or show BFD neighbors detail, you should see your state as up, and it again shows you as up, and the registered protocol is ISIS and Ceph. Now, if you want to check, let's say if you want to test this out, what we could do is now go back to R4 and shut down the interface to R4, and we would see that the convergence would be much faster. It would be less than 1 second, which means about 150 milliseconds. So let's go to R2 and go under the ISIS process and give the command log adjacency changes all, and also give the command service timestamp. That's going to be a global command. So service timestamps log datetime msec. Okay? And now I would go back and shut down my link to R4. Let's do a ping. So if you see right now, my trace route to 5555, I am transiting R4. Let's do a ping to 5555. Repeat 100,000. And my ping is working. And let's go back to 4 and shut down my interface gig 1.24. So the minute I shut down this interface, what's going to happen? BFD control packets is going to detect that the link has failed, and it will instruct ISIS to destroy the neighborship and reconverge. And this is going to happen in less than 1 second, which is 150 ms. Let's shut this down and look back at R2. I have all my pings here. In fact, I did not even see a single drop on my router. So I didn't see anything. Now, obviously, right now, my neighborship was basically flapping because I gave really less MS. I should retune my ISIS hellos to be sent at a smaller interval rather than being sent at every 10 seconds. So I should tune that also, otherwise you will have your adjacency going up and down. So let me go and readjust that. I will readjust my BFD interval to be a little bit longer. So my BFD interval would now be maybe 250. Same thing on router 4. My BFD interval would be 250. You don't need to change this. You can also tune your ISI's hellos to be sent at a smaller interval. And let's go back and do a no shut, gig 1.24. No shut. And you should see, because I gave the debug command, I should see my adjacency coming up, and I should see the debugs, because I gave the log all events of BFD, so log all adjacency changes, and I also gave the service timestamp, right? So let's say if I go and do a debug BFD events, and look at my show BFD neighbor detail. Currently my neighborship is up and running. My control packets are being sent and received. Absolutely no problem. And let's do a ping again. Ping works through R4. I will shut down again. And let's see what happens. So I see a debug. And my ping has started working again. And if I look at the time interval here, let's stop this. If I look at my timestamps, I should see that it's less than 1 second. Let me go back and do a shut, no shut without the ping. Yep, so I have this enabled. And do show run section router ISIs. I have the log adjacency all. So trace route to 5555. I should be going through R4 right now. Let's shut down the interface and let's look at how long it takes for it to detect that. And let's also go to 4 and do a debug. Debug BFD events. And let's retry this. So gig 1.24 shut or no shut. Let's wait for it to come back up and do a shut. And we can always look at it as show BFD neighbors detail. My neighborship has gone down because I do not have the BFD control packets being exchanged between the routers. So let's try our ping again just to see how much time it takes for it to reconverge based on our new settings, which was BFD interval as 250. So let's go back to 4 and no shut. Let's go back to 2 on all and do a no shut. And ping 5555. So to repeat 100,000 and shut down my link. So BFD neighbor is down, and the convergence was much faster, as you can see here. And again, if I look at my show BFD neighbor, I should not have any neighbors on my routers. So you can always verify your BFD. BFD basically instructs the ISIS process that my neighborship has gone down. You may bring your neighbor down. Without BFD, ISIS will automatically detect the neighborship again anyway, but it's just going to be much longer. With BFD, I can speed up the process for the neighbor to go down so that the routers can reconverge, and you would have faster connectivity. So I hope this video was informative to you, and thank you for viewing.